All right, here we go. So you've kind of got your toes wet. We got doing a little logarithm thing. We're thinking exponents. We're not too sure why. We're doing this because we're asking you to do it. But hopefully it comes a little bit better today. So let's look at what we know. I would love it if you have this one down pat, going from exponential to logarithmic form, backwards and forwards. Sometimes it's better by experience. You just kind of get a feel for what you want. The little example here is 10 squared equals 100, and log base 10 of 100 equals 2. So that's kind of like, yep, I can remember that. These are the inverses. So you're putting an exponential function into a logarithmic function. They're undoing each other, and that's why you end up with this and this being the same value. So if I was walking along in the woods and I saw a 3 and I wanted to rewrite 3, I could write it as log base 10 of 10 cubed. Just to be clear, I could write this as log base 2 of 2 cubed. Just as long as that base and those things are the same, life is good. This is a little bit more obscure. I'm still using the idea of plugging the logarithmic function into the exponential function. Those are inverse functions, so they should undo each other, and we should end up with x, and we do. So 159, go Alpine, can be written as 10 to the log base 10 of 159. Awesome. So laws of logarithms. Hey, if we were together, I would say, hey, let's everybody plug this in. So you would be given the task of plugging log base 2, or I'm sorry, log of 2 plus log of 3, and you'd get something. I wonder what that would be. And then for some weird reason, D, which is right below it, which has a lot to do with it, you might get something else. So let's say, boom, magic happens. And there's our solutions. Interesting. I'm just rounding 3 decimals here, but 0.778, 0.778. No way. Look at this, 3 and 7, 1.322. Oh, 21. I wonder if there's a relationship. And yes. So right now, would you please, what we do in mathematics a lot of the times is we make conjectures. We do a few examples. We'll get this, and we start saying, hey, I see a pattern, and then we take a guess. So if I took log of A plus log of B, how could, what's another way of getting that? I wonder if looking at all these examples right here might help the log of A plus log of B. Give it a shot. All right. I hope you did it. I hope you had fun. I hope you had an amazing thought process. What we're doing is we're trying to create some tools, some ways to work algebraically. So we make a mathematical model of something in the real world, and then we put those on in those models, and we work with algebra or geometry. Geometry and algebra, same thing, different ways. Oh, the geometric derivation of logarithms is just remarkable. Just remarkable. Another day. All right. Well, ladies and gentlemen, I hope that you took a shot here and you got these 3 rules. 3 rules. So if you add logarithms, it's the same thing as multiplying. If you subtract those, same thing as division. And when you multiply those, it's like taking a power to a power. Hey, I'm just going to throw this out. Just thought about it. Logarithms are kind of new, but I told you to, if you could, associate them with exponents. I'll just throw this out. What do you do when you have 10 to the x times 10 to the y? Well, 10 to the x plus y. There's a little bit of connection there. A little bit of connection. You got addition, and then you've got this multiplication. We've got addition, and we got multiplication. So it's kind of, well, that might, there, yep. Oh, I wonder if we took 10 to the x over 10 to the y, that's the same thing as subtracting those exponents. Cool. Well, just thought I'd throw that out. We also we don't really believe that you need to do this in a different section. So the C here stands for any base that we have. If we chose E, the number E, then remember that the log of base E of x is really kind of, people might say log or something weird. So we're going to use this a lot. It's beautiful in calculus. The curve is so just glorious. So we don't say log. We say that's the natural logarithm, and we shorten that with natural log of x. So please understand, ln is not a log natural. It is natural log, and it is a log base e, just like log base 10 or log base pi or log base whatever. It's e. Very useful. All right. Well, in this class, I do want you to know that I'm going to expect that you can derive these things. Okay, I think it's really important. So what I want you to do is use the tools that you have in order to get to this spot. All right, let's look at it. So here's the derivation. I'm going to derive the first one, and then I'm going to ask you at some point, quiz, test, final exam, to derive the second one. There's a lot of similarities there. So here we go. What we're going to do now first is we're going to tell the world, we're going to set it up. We're going to set the stage. I'm going to just let x equal to log base c of a and y equal to log base c of b. No big deal. I'm going to move my picture, I hope. Maybe I am on the struggle bus with that. I had to get a hammer. All right, so that's easy enough. So in a derivation, it's like you're not asked to do this on your own, but you might as well appreciate the steps that somebody else did. This is a relatively straightforward one that maybe you could do it. I don't know if I could or not. It's just like but I think we should challenge ourselves to, one, pay attention when you're given a derivation and appreciate the steps or the ingenuity that goes along with it. So I think a good thing to do is give you all the steps and then maybe ask you to come up with, what did they do from this step to this step? Well, we just converted logarithmic form to exponential. All right, if x equals log base c of a, then we know that c to the x equals a. Awesome. All right. So then you have to start somewhere, and this is where it's challenging as a math teacher to teach derivation, because you're like, oh, well, sure, I would just start there. Well, just pay attention. We're kind of given this top part, and we're just going to say that a times b. I wonder what a times b is. Well, we know a is equal to c to the x and b to c to the y, so we write it like that. Maybe I bring your attention to this. I wonder what we could do with that. Absolutely, follow your gut. We certainly can, since they have the same base, we can add those exponents. And this is just an exponential function. Something equals something to a power. So we should be able to rewrite that in logarithmic form. So log base c of this quantity equals the exponent. Nice. But wait a minute. What is x and what is y? I'm going to drag this up just a little bit. There we go. So x is log base c of a. So we just substitute that in. Y is log base c of b. And guess what? We're done. We have just proven through steps that we already knew that were true, and we derived this relationship. If I have log of AB, I can rewrite it as log of A plus log of B. Or vice versa. If I have two logarithms, I can write it as a single logarithm. I think that direction is actually more important. And no derivation is done without a good bam. All right, you're psyched. You got it. Man, I use tools. Feels good. All right. All right, let's do a bunch of examples. Here we go. Use the laws of logarithms to write the following as a single logarithm or as an integer. You can't read that because I've successfully covered that up. There we go. We should be good now. All right. This looks like we're adding logarithms. The rule of adding logarithms is multiply those arguments. So, is that easy? I am not expecting anything more. All right, let's go to the next one. Actually, you give it a shot. I'll give you a second to pause. And we're back. Subtraction means division. And you could leave it as 24/8. Come on, you should get a higher pay raise than that. Last one's interesting. We worked a lot on changing the base and writing that. Can you work backwards? It's a challenge. So in this one, the first thing I would do is change that 1 into log base 2 of 2 to the 1. Why did I choose 2? Because of this base right here. That's my choice of why I chose that to be a 2. Well, that's just good old subtraction, which implies division. Awesome. All right, simplify by writing as a single logarithm. I think this is probably the most important skill because one side of an equation you need to probably put together. Before we called that combining like terms or simplifying. So it's important. I would say you need to address any numbers out front. Out front, like out front of the house? No, like the numbers out front here. Those really have to be dealt with in order to put the logarithms together. Okay, the rules are log of A plus log of B, not 2 log of A or whatever. So make sure you deal with those first. Let's check it out. On part A here, the first thing I do is I use rule number 3 and I make those the exponents. So I bring those out. I'll leave the negative. I can bring the negative, change that to a positive. It's cool. It all works out the same. So subtraction, same base. I can rewrite like that. Could I put 49/8? Absolutely. All right, let's look at 2, or part B. Part B is one of those where I need to really kind of be working with logarithms. So it's kind of working backwards. I'm going to choose base 10 because this base is base 10. The 2 comes up and we're off to the races. Addition means multiplication, and I multiply those, I get 9,000. C is tricky. Oh man. And pay attention. Listen to me when I say pay attention because you'll see something like this. There's no form. We haven't had an equation like this. I will tell you right now, oh my goodness, this does not equal log of 8 minus log of 4. That is not correct. Bad. I'll even write bad. This is, I'm trying to make a big idea because people see division, they think subtraction. Look at the form. It's not quite the same, so be careful. I see an 8 and a 4. I've been working with these. Base 2, I think. I like base 2. Check that out. Log 2 cubed, 2 squared. That number can come out front. And then what's log 2 divided by log 2? That's just 1. So this, ladies and gentlemen, is equal to 3 halves. Because this cancels that. That's pretty cool. There's your rational number. All right, show that. Hey, the word show in IB means I'm going to give you the answer. So they give you the left-hand side or the right-hand side, and you start there and you try to work to the other side. That's the goal. All right. So natural log 1/9, I'm supposedly supposed to work that to get -2 natural log of 3, or vice versa. And it doesn't matter which way you start. You just follow the rules. So I'm going to follow the rules here. And so what I did is I rewrote the 1/9 as 1 over 3 squared. I pulled that up using the negative exponent law, and then that -2 came out front. And I got what I needed to get. It's kind of weird. Sometimes those are really hard, and if you don't get like this answer and use it later on in the problem, then you don't get any of the follow through points. So in IB, they try to help you out if you're going to use that solution over and over again. All right, this one, just to show you, I'm going to work on the right-hand side and see if I can get log of 500. So I take the 3 minus log 2, and I need logarithms, so I'm going to convert that 3 into log base 10 of 10 cubed. I chose 10 because that's the base I'm working with everything else. Subtraction means division, so I write that. Get the division, and I'll bet any day that you know that 1,000 divided by 2 is our good friend, log of 500. I don't know if you can see that, if it's behind me or not. Whoa, okay. All right, probably the most questioned problem set we have. Anytime you see a log base b of 2, you plug in a p. Anytime you see a log base b of 3, plug in a q. Anytime you see a log base b of 5, plug in an r. Well, I don't see a 2, 3, or 5 here, so the whole idea is to take the argument. When I say argument, I'm talking about this part, this part, this part. That's what, when I say the argument, that's what I'm referring to. And you need to rewrite it in terms of 2, 3, and or 5. And in really sticky problems, if you can do the same base that you're working with, that can work out too. That's kind of a... All right, so can you do something with 6 and put it in terms of a 2, a 3, and or 5? Well, it's pretty obvious that 6 is equal to 2 times 3. So when we say log of 6, we can rewrite it as log of 2 times 3. Multiplication means addition. So now I can break that up into 2 separate logarithms, and now I have my log base b of 2. So I see that here. I can replace it with a p. Log base b of 3, I can replace it with a q. All right, seems easy. Let's try D. Well, D is pretty cool because I already have a 5, a 3, and a 2. So now I just have to pay attention to my rules. I took the square root, made it 1/2. Do you see how this is multiplied by this and divided by this? I want you to really quickly learn that you can do this all in one step. So positive, positive, negative. And these two are going to be added, and then we're going to subtract that. So I can do all this in one step. Feel free to do that. Log base b of 5 plus log base b of 3 to the 1/2 minus log base b of 2. Now we're off to the races. Really not a lot to do here besides win, win, win. R replaces this. I pull the 1/2 out, and then the b, and then now I can substitute in for the q. This isn't q to the 1/2. This is not q to the 1/2. It's 1/2 q. We've got to pull that out front. Well done, well done. All right. Same idea, actually easier, because here you're given r's and q's, and you don't have to rewrite the numbers. You just have to split these up into single logarithms, or I'm sorry, into multiple logarithms, and then once you have log base 2 of p by itself, or of something multiplied, then plug in that x. So let's try. Let's try E, this one right here. I see a q cubed, r, I'm thinking r to the 1/2. Wow, I jumped ahead here. So got the q cubed, got the r to the 1/2. It's division, so that means subtraction. I'm going to pull out the 3 and the 1/2, and now I have enough to substitute. So I believe it is y and z. I'm going fast because I've done this 1,000 times. I hope the idea is really what you're walking away with. All right, write these logarithms in. This is kind of, I'm not a big fan of this question because it's like, why would you introduce logs? Well, then I thought about it. You want to introduce logs all the time. Give yourself that tool. All right, so if we want to introduce logarithms, just take the log of both sides. Base 10, base 5, base e, whatever you want. This tells us we'll just use base 10. So on A there, I took the log of both sides, and then I'm good with this. That's the answer. You've written it in logarithmic equation, but I'll bet they want you to show your stuff. This is multiplied, so we split it up, and then the 2 is with the a squared, so I move that out front. That's all there's to it. These are getting a little bit more interesting, but I thought I'd give you these notes. The idea is if you can whittle it down to log A equals log B, then your next step is just get rid of the logs. Your next step can say A equals B. That's pretty cool. But if you get the one log on one side equals a number, then you go from logarithmic to exponential. Both ways kind of get rid of the logs, and it may or may not be the right way, but it usually helps, and then you just finish solving for x. So let's try an example. Let's go with A. So I've written it. Sure, I know people are thinking, oh, that's 3 cubed and that's 3 to the negative 1. Yeah, I could do that and kind of do some stuff. I'm just saying I solved it this way. If you see that and you want to do it that way, go for it. I see this as addition, so I'm going to multiply. I get 9. Now I've got log base 3 of 9 equals log base 3 of x. Well, if they're both the same log base 3, then that has got to equal that. And then that's our next step. 9 equals x. Hey, man. But if you saw a different way, go ahead. And sometimes I'll be faster, sometimes I'll be slower than you. It's cool. This is a cool one. This is B. If you go up to B real quick, I have subtraction here, so that means to me division. So I divide by 8 by 6 minus x. That's why that happened. I got log base 5 and log base 5 of one thing. There's nothing else out here. I've got this and this. So that means I can just drop it. So I just get x is equal to this quantity. Well, I'm not out of the woods yet. Now I'm going to multiply both sides by 6 minus x. Cancels it on this side, comes up here. Wait a minute, I know what you're thinking. Yeah, quadratic. Woo! I love it. And how do we solve quadratic? Well, rely on our amazing skills. I'm going to factor this bad boy, and I get 2 and 4. I will tell you that very rarely do both work. Really, most of the time, one of them doesn't. So this is pretty cool. Well, what do you mean work? That means I am plugging it all the way back into the original equation. And plugging x equal to 2 in here and making sure I am not taking the log of a negative number. I'm going to say that again. If you plug a number back in to check it and you end up taking a log of a negative number, it doesn't work. Maybe later in the derivation you square both sides so it doesn't matter. Nope. Doesn't work. It's not acceptable. All right, natural log, same thing, but base E. So darn, I bet this is an easier problem than you've done all day. How would you solve this? Well, go from logarithmic to exponential. Whoa, that's not right. That's not right. So boom. Boom. I would accept y. Okay, we're starting to lose it. I would accept that as my answer. If you want to plug it into your calculator, you can do it. Ladies and gentlemen, there's a lot of practice. I bid you good day. I am here to help you. I have made my copy of that, and I've hinted on a lot of them, so feel free to use that. But I will be there for you in class. I am hoping that you crush it. Thanks.